All right, so Theresa, if you're ready.
I'm ready.
All right.
So hi, I'm Theresa Good. I'm currently the Division Director in Molecular and Cellular Biosciences at the National Science Foundation. But I am a chemical engineer by training, and did a BS in chemical engineering, and my research project as an undergraduate was on cement hydration, which wasn't particularly exciting and did not inspire me to go to graduate school. But somebody twisted my arm, and I went off to Cornell and worked on mathematical modeling of E. coli. And after 2 years of doing that, I couldn't figure out why anyone would care about the models I was developing for E. coli. And so I dropped out of graduate school and went to the Peace Corps for 2 years, where I discovered I loved teaching, and that the little bit of biology I learned while mathematical modeling of E. coli was useful in the Democratic Republic of Congo. But that I didn't really like living in mud houses and couldn't do that for the rest of my life. So went back. The only thing I knew how to do is program in Fortran and grow bacteria and fermenters. So I got a job at a pharmaceutical company doing vaccine manufacturing. Did that for a while, discovered that it really didn't, my job didn't change very much when we moved from one vaccine to another, because a bacteria in a big tank is a bacteria in a big tank. And so I got bored. I had a couple of other jobs, and then at some point discovered that the only way that I was ever going to be able to do what I wanted to do was to go back to graduate school and finish my PhD and have my own lab. And I went to Wisconsin, finished PhD, went to Texas A&M, was a professor, moved to Maryland, was a professor. And then around, 20 years into that, someone said, why don't you come to NSF and be a program director? And I was like, program directors, that's such, they don't talk to you. They don't do anything important. Science is where it's at. The discovery, being able to do the research, teaching, this is so cool. And I got there and I discovered that you really can have a big impact on the direction of science by deciding where the money goes. And that is what I do now, is I help decide where the money goes. And I work with people across the agency, especially in physics, to try to figure out what new programs we should develop to enable the science community and scientists to really innovate in different ways. And the moral of the story is, until you, I think, change is, if you're not happy doing what you're doing, you should continue to keep on looking for what is gonna make you happy or more satisfied, and that there's lots of things you can do in science, and that to continue to discover and have impact. And so with that, I'm gonna hand off to the next speaker. I'm not sure which one of you want to go next.
You get to nominate.
Oh, then hi, I think it's you.
I should not have said anything. Thank you, Theresa. I was going to say Sarah, but yes, so my name is Tai Wing. So currently I am the branch chief for future technology and capability in the Office of the Secretary of Defense, OSD. I'm an atomic physicist by training. I wanted to teach high school, actually, believe it or not, way back. I was the first person in my family to go to college through the Upward Bound program. I'm not sure if you ever heard of that. But essentially, I wanted to teach high school math. But I didn't know what to do. I did not get my teaching license in the state of Wisconsin. I grew up in Green Bay, Wisconsin. And so I went to graduate school, not knowing what I wanted to do. Got involved with building something called a magneto-optical trap. And this is the precursor to the Bose-Einstein condensate. And so I got my PhD from Kansas State University and got a a high-profile postdoc at the University of Paris, working for Professor Alain Aspect. We back in 2003, 2004, 2005 timeframe, we put something called a Bose-Einstein condensation on a chip and sent them out to satellite for the French government. And so this thing has the potential applications in GPS and PNTs and things like that. And so I came back to the US after a couple of years of postdoc in France. And then my professor said, hey, why don't you apply for Wisconsin, Madison, that's your home state, get a faculty position there, get a Michigan State, you name it, you should go to these big schools because you get this big name associated with you. I say, no, that's not exactly what I want, sir. I want to teach high school. And so I ended up teaching at a small college, the University of Wisconsin-Stevens Point, which was really close to my home. But then I decided at that time that I wasn't gonna die in Stevens Point, Wisconsin. I don't want to have the rest of my career there. And so I moved down to the East Coast, got a faculty position here at the University of Mary Washington, just in Fredericksburg, Virginia. And I became the chair of the physics department there for a few years. I took them through the 5-10 years review and things like that. And so throughout that time, I've been advising a lot of students who apply for the Goldwater Scholarship. And I kept telling them, hey, what is it that you want to do 5 years from now, 10 years from now, 15 years from now? What kind of impact are you going to make in society? And guess what? I asked those questions for myself. What am I doing? And so after being chair for 3 years, my first time around, I said to my dean, I said, I need a sabbatical. So I got on the AAAS Fellow working in the Department of Defense. They needed an atomic physicist, and I was the one. And so I worked for them for a year and a half, and they turned me into a GS-15 position. I worked for the Undersecretary for Defense in Acquisition and Sustainment. And here I am a year and a half later. I'm in that position right now. Over to you, Sarah.
Thank you. So my name is Sarah Sharpe. I'm a biomechanics consultant at Exponent, which is a very large consulting firm. And I'm a senior manager there. A little bit about how I got here. So I have a bachelor's degree in mechanical engineering and a PhD in bioengineering, but I worked in a physics lab during my PhD. So my motivation to go to grad school came when I was in my undergrad. My controls professor came up to me and thought I was doing really well in the class, and he asked me to do some research. And I was able to work on more of I'd say a bio-related project where I was looking at functional electrical stimulation with frog muscles with some implications for potential human applications. And in doing so, I also started thinking about changing over to more of a biomechanics, bioengineering background. Had an opportunity to do research experience as an undergrad at Georgia Tech, was in a neuroengineering lab during that time, and I really loved it. And so I decided to go ahead and to pursue a graduate degree and started my PhD at Georgia Tech. I actually had an NSF 2-year fellowship, and it required me to rotate around into different labs. So I had to choose 3 labs for that first year. Rotating, I had 2 neuroengineering lab professors, and then one, I found Dan Goldman in our physics department, and he had some things that were on the cusp of this bioengineering as well as physics, where he was trying to understand movement of living systems in complex terrain. And so I thought, well, I'll give it a shot. I'll try to rotate in his lab, and I just really fell in love with it. I really liked the work that we were doing, and that I could contribute from more of the biological side, and I could work alongside the computational physicist in his lab. And so I decided to actually stay in his lab for my PhD. but my degree is in bioengineering. I like to think that I have some honorary an honorary physicist, although I don't have the technical degree. So learned a lot about physics in his lab. And I was one of the people that I would say wasn't sure whether I wanted to do an academic route or a industry route. And I ended up going to industry, saw somebody from Exponent come and present and said that I could basically apply principles of physics and mechanics to the human body. And that got me intrigued. I came out to our facility here in Phoenix, where I'm currently working, and we have a huge test facility out here where we do car crashes, and we just have a big laboratory where we can do a lot of different things. So I thought that looked pretty exciting and interesting, and also had the potential for doing some amount of research as well and publishing, which I still do, even though I'm not in an academic environment. So I decided to go ahead and choose industry, make that switch, and I'm so glad I did. I really enjoyed it. I really love it, and so now I am here. Just a little bit about Exponent. Exponent has over 90 different disciplines. So I'm in biomechanics. I tend to deal with human injury, but we have just a ton of different types of disciplines where I work.
Great. Thank you, Sarah. I think Eric is our last person.
Hello, everyone. Can you guys hear me well?
Yes.
Great. So this has been great. I'm grateful to be here, especially given that this is in Texas. For those of you, when I started out, I was very interested in forensic science at the time. I had a physics kind of inkling of what I could do. It all started at HEB. For those of you who know what HEB is. Started out as a bagger, and then I really got into from that, wanting to kind of pursue science. But it was hard, I was also working, right? And then came along the Mark U-Star program at UTSA, University of Texas, San Antonio. I was in the physics program there, really fell in love with what you could do with physics beyond, forensic science. I really got into biophysics, started working with tubulin and actin cytoskeleton. And then because of that, that's what really propelled me to go to grad school. And so I'm thankful for that kind of opportunity. And I'll kind of circle back in a minute as I wrap up, but it was really those kind of mentors that pushed me forward. And from that, I got to go to Illinois and do the biophysics program, where I got to work on microfluidics for single cell trapping. So I was working with E. coli and trying to look at how we could phase in different antibiotics and how they would be affected under planar extensional flow. It was a really great experience, got a combination of engineering, biology. And at that time, I wasn't really sure I wanted to continue doing science. Even though I had an NSF GRFP, I was thinking about the Presidential Management Fellows program. It was at the time when they did STEM track. It wasn't clear on how agencies were going to hire. And so instead of doing that and waiting for that opportunity to pan out as a finalist, I decided I wanted to continue doing science. And so I felt, I was able to recruit and invite a PI from Yale, Enrique de la Cruz, phenomenal mentor. And from there, I got to go kind of like dive back into more of the protein work, applying my knowledge with microfluidics on actin cytoskeleton. Fortunately, was able to write for a postdoc fellowship with NSF, did 3 years, and then realized, where I was going, obligations, family obligations, that I wanted to kind of, find a way to kind of apply what I did in a broader sense. And that's why I think AAAS called to me at the time. And so I applied to that, came to DC. And so that was a great opportunity. And being at Yale, I got to work, I'll call out someone who's on the call, Dora Noble. It's great. She's part of the physics, engineering, biology program there. We got to collaborate on K through 12 outreach. And so because of that, and also my training background, it kind of stuck with me and continued to do what we all do, is mentor on the side of our kind of our core mission, right? And so from that, the AAAS program, I got to go to NCI, National Cancer Institute at NIH in the Division of Cancer Biology, got to work on innovation labs, got to be involved in these cross-collaboration with NSF, being able to have conversational chats with Theresa on synthetic biology and in our innovation lab comparison notes. And so it was a really great experience to kind of be able to bridge off what I've done in a broader context, to work with PIs, to have really get them to be collaborative. And then from that, we also did challenge prize competitions and kind of the metadata data science space. And so fast forward, that was a 2-year stint at NCI. I decided I wanted to kind of continue on, but kind of get more into the training. So now, as of August 2019, I'm a training director for the Center to Reduce Cancer Health Disparities at NCI. And what we always argue is there's really no alternative careers, right? You are a scientist first and foremost, and there's careers that allow you to apply your thinking in that broader context. And so, I know this is a career panel, but I'd be remiss not to mention it. For those of you who are still figuring out where you want to be, but are interested in cancer, the ICUR program, which is the Intramural Continuing Umbrella for Research Experiences, recruits postdocs, undergrads, and postdocs, and graduate students to come to NCI to do cancer research. So feel free to email me after this if any of you, if that is an interest of you. But overall, it's been great. And, I think working with a lot of these colleagues here and seeing familiar faces, it really kind of, it goes down to what you want in terms of your career, and then making those connections and finding those mentors that will help support you in that endeavor. So thank you for the time. And yeah.
Great. Thanks so much. It is fun how small a world science can be, that someone you knew in grad school, you'll bump into again later on, or it is a small world. So now I think we're ready for student questions. Y'all have, who's got a question? And if you want to turn your video on so we can see you when you ask your question, that'd be great.
I can start. First of all, thank you so much for everybody who's coming in here, giving us the opportunity to talk to you. My questions is specifically for Sarah for my first questions. What is the difference? Because it sounds to me that even though you are in the consulting now, it is in the engineering consulting, so it's probably similar to what you've been doing as a PhD student or a postdoc, right? But are there any significant differences between the two?
Sorry, between industry and postdocs?
Specifically in your the engineering consulting, because I know management consulting can be very different, right? But I'm interested in specifically the engineering consulting.
In engineering consulting. So, and not just between academia and engineering consulting.
Yes.
Yeah. Okay. So, well, I would say just, and maybe not engineering consulting, but just any kind of scientific consulting specifically. A big difference that I found coming from an academic environment over to consulting is the fast-paced nature of it. I always say that I could work on an abstract for a week, right? Refining it and making it better and better. And I can't do that in consulting. One, because I bill hourly to clients for my work, and they won't let me spend 40 hours on something. I do have to become very efficient with my time, and I have deadlines, right? I have multiple deadlines, and I need to be pretty quick about it. So very deadline driven in the consulting business, very fast paced, and so that's a big difference that I have found. In terms of that, and a lot of diversity of projects. So I could be working one day with somebody who calls me and wants to know, what's the sort of loads that this produces on the body, and how do people move? And I want to redesign a product device, and then I get a call, and there's an injury that has occurred where somebody, maybe it was a bike versus a truck incident, and they want to know, did this story match, right? So I have a lot of diversity of projects that I'm constantly working on, and so it changes too. So instead of maybe a more in-depth focus, it's much broader. So I would also say that's the big difference, a broader scope, and maybe I'm not going as deep into an issue.
I see, thank you.
Great. Who else has a question?
Hi, I have a question for those of you in government. So how is it different working on like the policies and the funding side than it is like when you were working on your pure like theory research in academia?
So, hi, why don't I start and then you go, and then Eric, or, well, I'm jumping in anyway. So, one thing when you're working on policy that a lot of the direction that you get is from above, not so that as an academic in my own lab, I worked on whatever I thought was really the most interesting problem that I could solve, and whatever I could convince someone to give me money to do. And so it was always directed by me. And the graduate students and the postdocs that were in my lab. But right now I'm working on developing policies associated with industries of tomorrow as they relate, and how you might use biotechnology to address industries of tomorrow, and how you might integrate quantum and AI into those industries. This is not my scientific expertise. It is. And would it be the first thing that I would work on? Maybe not, but that is what the president has said. We are going to solve climate change. I am going to develop programs that solve climate change. And so that is one of the things that certainly changes. And I think you end up having much more breadth than the depth that you have when you're working on your own research program. So hi, and Eric, you're very different, you're in different parts of the government, so you might have really different perspectives.
You want to go first, Hi? Oh, you're muted right now if you wanted.
Oops, sorry, I was on mute. I muted myself, my apology. Theresa, you and I, and Eric too, we all have the same boss, that is the president. And in fact, in my line of work in the executive branch, we serve the president. In fact, the area that I do, NC3, Nuclear Command Control Communication, that is the president. And so responsible for presidential communications through various environments. And so my job is to make sure that the policy that roll out adhere to particular policy driven by the White House. And also whatever that scientific advances or technological transitions that I developed, the policy that we need to write has to adhere to that higher calling that is from the president or the White House. And so whatever that line of efforts or technology, quantum computers, AI, ML, machine learning, and things like that, if they do have a validated technology readiness level, I would consider them. However, within the department, because and people debate whether that the department is bloated or not, but within the department, every single dollar is accounted for and where they ought to go. And so we would have to develop a framework in which we have to have a validated requirement. That is to say, if you don't have validated requirement or whatever policy that's driving it, no money is going to go into it. And so in a sense, whatever policy that we're trying to write, it has to have the pedigree, the scientific backing, as well as the validated requirement from the president. Over to you, Eric.
Thanks, Ty. Yeah, to go to both Hai and Theresa's point, it does take time, and you have to engage your colleagues, external stakeholders outside your comfort zone, right? So you kind of have to develop these interpersonal skills, working with others, being able to allow others to engage in conversation, to give their feedback, to really build upon it. And it does take time. It takes that, that initial effort, that learning curve to kind of get familiar with the space, know what's being done already, and then try to build upon that, right? And so luckily, where I sit, we're kind of layered. We have many layers of leadership that reach all the way to the White House, right? And so we're always there's requests for information. We have to put together proposals. You guys seen the news, everything coming out with the new initiatives. So really being ready to go at the table, and this may, depending on where you sit in the government, you may put up a whole bunch of ideas, but only a few will get pushed forward, right? But that it's always churning like that. And you're always trying to push the envelope and to kind of come up with these ideas that can be actionable, right? And what the feasibility of doing these types. And in comparison to what you've done in the lab, it's really kind of, you're really focused on, you're the champion for your project, right? Working in the government, you have buy-in from a lot of people. And so you want to make sure you get all that feedback and to push it forward and to really vet it. And you'll have many opportunities to do that along the way. And so I think, you know, being able to not be afraid and apply that skill set broadly is the exciting part about it, because everything's always changing. There's always these new initiatives. I think it gets to a point of, you know, making sure that you're not saying yes to everything. Being judicious with your time management. So that's one of the things that I learned real quickly is, you know, in a research setting, you tend to throw your time and your effort to your project to get it through. In the government, you know, it's efficient in terms of the 9 to 5, but there's times when you have to push for deadlines and kind of get things done. And so being really conscious of that. And also, you know, looking ahead 2 to 3 years, fiscal years ahead to really see what's going to be coming, you know, and really making that effort to plan accordingly. So.
Great. Would that answer your question, Madeline?
Yes, thank you all.
Okay, great. Who's
Eric,
next?
I see a question on the chat for us to talk a bit about our AAAS fellow experience. So why don't you go ahead?
Great.
Okay. Thanks, Hi. So I was a 2017, 2019 fellow. I applied right before the 2016 election, was really conflicted, decided that, you know, DC was still what I wanted to do, came. And it's been a rewarding experience. I had one of the, you know, my boss at the time, my supervisor at NCI was great. She allowed me to be a part of all these initiatives to really kind of get an idea of what I wanted to do and what I wanted to engage in. The fellowship experience is great, both between PMF and AAAS. There's differences in terms of what you want to do, but for the AAAS, I think it was exciting in terms of the interview process. I know now in the past couple of years they've done virtually, which is kind of hard, and you kind of miss out on the actual networking. But once we kind of get back into those open opportunities, you know, as we come out to be able to be in person, I think AAAS is great. You know, we have, you know, weekly meetings where we can meet with other AAAS. It's like over 200 of us at any given time. You're part of a larger network. At NIH alone, and I know the other agencies as well, there's vast former AAAS fellows that you can actually tap for resources and knowledge and kind of get an insight into what they're doing and kind of helps in terms of resources. And then also the professional development is great. And I think having that camaraderie in DC is really the kind of the winning part of AAAS. And then, you know, having that buy-in, depending on what agency you're in, you're already there, you're familiar. It kind of helps you, if that's something you want to do long-term, to kind of convert to an actual federal employee. And so it's, you know, not all fellowship experiences are the same. And they're so vast, but from the NIH perspective, I think it's been great in terms of, you know, the resources provided. And what I'm doing now, I think working with postbacks, grad students, and postdocs has been great and rewarding experience for me. And now I've kind of expanded that in terms of working with the consortium on cancer health disparities. So, you know, in a nutshell, overall, I think having that group and that network has been really impactful in terms of my career trajectory. Go ahead.
Yeah, great. Thanks a lot, Eric. Yeah, so when I took my sabbatical year, I wanted actually to work for Senator Tim Kaine on the issues of state funding for the higher education. And so, but at the time, 2018, he was up for re-election. So I didn't know whether he's going to get the, but in the state of Virginia, he was pretty much in. But he's still there now. As it turns out, working for the Department of Defense. He's now on one of the Senate Committee on Defense issues, and so I get to see him again. So, but as it when I accepted the position with the AAAS fellowship, and I can attest to what Eric had said, about the training that you get when you get to be a AAAS fellow. I don't know if you remember Miss Crane, Eric. She taught us how to hold wine glass on the left hand and shake hand on the right hand. It was a eye-opening experience that you take away your safety goggles, your lab coat, and you put on a suit and tie, and they teach you how do you carry yourself and how you deliver that 2-minute elevator speech to people to sell your ideas. And so it's a great opening experience. And in fact, during that week of training, I had the opportunity to sit at the same table with Nguyen, who was the former Secretary of the Department of Energy. And I introduced myself. I said, Dr. Tai Wing, I teach at this small little arts college, teaching students to be well-rounded. So you probably seen him around DC. He's a smart stature man, very recognizable with his hair, waving white hair. He leaned on the table and looked at me in the eyes and he said, well, hi, well-rounded people don't have a point. I was taken back by that, but he really said, no, calm down. He said, well, what it means is that you got to drive those people to have a purpose in life. They're well-rounded, they're well-prepared, but they have to have a purpose in life. And so that sort of people you get to meet in your fellowship. And in fact, as it turns out, during my fellowship, it seems like almost every door I knocked, including the OSTP Office of Science Technology Policy at the White House. Every door I knock, it seems to be there's another AAAS fellowship on the other side of the door. Open up the door and say, "Hey, hi, what do you need?" And so it's that sort of base of network of people that you get introduced to, and that's really instrumental for me, because at the time I was writing this strategy for nuclear research in the US, and I was representing the department, and the person who was writing it was at OSDP. He was a AAAS fellow. And so it was a really collaborative project. And so that's why it was meaningful for my host office to say, hey, it looks like you're working well with a lot of people here in town. It seems like you represent us well, and we think you should apply for this position when it comes up. And so I think it was really meaningful and instrumental for me to get the position I get.
Great, Troy. Okay, Troy is satisfied with your answer. What else do we want to do? Who else has a question?
I have a follow-up questions for Sarah.
Great.
Do you think firms like Exponent pay attention to your previous research experience, maybe like publication history?
Did they pay attention when I was hired at Exponent?
Yeah.
So one, I'll answer that from two perspectives. One, my process being hired, and now I'm the lead in the biomechanics practice, what we call lead recruiter, and I organize the group of people that recruit students right now. So so I'll let you know my perspective when I'm seeing, viewing people's CV. So one, at the time, I think I had two publications, three maybe, but one as lead author, and then I had a few as in press, and I was a little worried. They did ask me about it, and luckily those they were in press, and a couple were being considered for publication, and so I did let them know that. But they were interested in it at Exponent, at least. And I am somebody that when I see a CV and I don't see publications on there, it's a red flag for me, because I want to see that people know how to get in depth in a project can effectively write about it, right? That they have those writing skills. We do so much writing and reports, and you have to know how to synthesize a technical analysis and get it out there. And so I'm pretty impressed. We just hired somebody actually that had something like 30 plus publications, and I was like, yeah, we're getting him in. I want to know who this is and see if he has the other skills to back it up. So that was like, for me, really impressive to see coming in. So it certainly does impact. Now, I've seen people with, 2 to 3 publications come in, get hired, have all the skills, can present to us, and that's sufficient. So there's no minimum number, but you've got to have some. So now the content, I was an oddball that they hired a little bit in my practice. The content is not always important, just that you can do those technical analyses, and that we're seeing you can get in depth and get very technical in a specific field, and you can convey that in a clear manner.
Makes sense. Thank you.
I would second what Sarah just said about writing. I know writing is very hard, but you have to be able to convey complicated, really hard to understand with so much jargon. You have to kind of distill down to something that a policymaker could understand, and you have to be precise with your language. I had a report to Congress where I sent a report where there's multiple things that's going on in terms of satellite environment, and I had to kind of it's not a dumb down. I have to distill down the essential information and report to Congress about the nature, the state of our satellite systems. As it turns out, when I wrote the report, I wrote one report to the House and one report, dissimilar report to the Senate. And as it turns out, the lawyer turned back to me and said, no, you cannot write this. You cannot write one report to the House and similar report to the Senate. It has to be identical. So it took me 2 weeks to kind of review those and go through the wickets to make sure that the language is exact. The identical letter is going to the House, and identical letter is going to the Senate. And so you have to be really precise with your writing.
Who else has a question?
Can I make a comment here, Margie?
Sure.
Theresa is here, and we have a lot of graduate students in this way. They're hearing a lot about other options. People ask, I think it's been a great meeting. First of all, let me thank all our 4 speakers for coming today. I really appreciate you guys helping our students. But Theresa, I want to talk about new postdoctoral opportunities at the NSF. I think you talk about a lot about your career, what was, I think, was very inspiring, but I think it'd be interesting for the students if you could tell about which choice they have in terms of independent postdocs they can apply. There are a lot of new things I'm observing. Maybe you can give them a hint of what's happening.
So I probably didn't look up all of the postdoctoral programs in physics. I'm wondering if Wilson is online and he's going to text them to me in a minute. But I can, but there have always been postdoctoral fellowships in the biological sciences in specific places, but there are more and more opportunities for postdoctoral fellowships at NSF that we support independent postdocs. But again, I wish I had thought about what MPS is doing, because most of you aren't going to, within the biological sciences, there is a kind of broadening participation track, a plant sciences track, and
Theresa, let me intervene a little bit here.
Yes.
Most of the people that have been working into this post program, although a lot of people come from physics, by the time that they go to postdocs, about 2/3 of that end up in biological places.
Thank you then.
Really the impact goes beyond MPS for all the people that we have here.
Great. So then within the biological sciences, the newest postdoctoral training track is, and we're moving from funding postdocs for 2 years to 3 years, but that they're in the area of understanding the rules of life. So we're really looking at people who can apply interdisciplinary approaches to look at problems that cross multiple scales of biology. So that going from the molecular to the organismal scale, or from the organismal to the environmental scale. And certainly a lot of the theory and physics that I have seen applies across those scales, or some of the most pressing problems in really understanding and applying physics to biology. If you're trying to understand development of form and function, that really does apply across multiple scales. So again, it is the postdoctoral fellowships in biology program. It's in the Division of Biological Infrastructure. There are probably some new things that we are doing now, kind of to respond to COVID, but these are, independent 2- and 3-year postdocs for that. The other thing, and this is kind of an aside, one of my other jobs within NSF is I am on the board of trustees for the Human Frontier Science Program. And so if you were interested in an interdisciplinary postdoc where you left the United States to go study someplace else, that is actually that very few US scientists actually do that. And the people who are in most demand for those postdoctoral fellowships are people who bring in interdisciplinary approaches to solve any problem writ large in the biological sciences. The current Secretary General of the Human Frontier Science Program won a Nobel Prize in mathematics, to look at climate change. And so really the ways that we look at what biology is and what biology does in the Human Frontiers Program and the interdisciplinary approaches that are applied, I think that if you wanted to do a postdoc outside of the United States, that is actually a mechanism you ought to think about. So NSF for biological sciences, Human Frontiers. And if you wanted any of those websites that to link to those programs, then I'm happy to send them to Margie or Jose or anyone.
Yeah, you can send it to me. That'd be great.
So Theresa, I have one follow-up question for that. If you're awarded an NSF postdoc fellow, are you going to be affiliated with the university or a national lab, or how does that work?
So NSF awards the fellowship to the individual, but we do that, and it's awarded to the fellow, not to the institution, but the assumption is that you will have a sponsor at an institution. We really are not, I haven't seen any of them go to a national lab. And so I think that there's got to be other mechanisms, and there are National Research Council, other things to get, to do postdoctoral fellows at national fellowships at national labs.
Thank you.
All right, who else has a question? Maybe just one or two more?
Yeah, I kind of have a two-part question.
Go for it.
Just based on the divide between industry versus the government positions. So since Theresa was already talking, I guess I'll hop off of Jose's question. So there are all these fellowships and opportunities for us, but what is the best way as us for graduate students, besides a solicitation, to maybe, is there any appropriate way for us to talk to people like you if we become interested in a program, to maybe get more information if it seems like appropriate that we apply to a particular program or something like that?
That's easy. The best way to get money from NSF is to talk to your program officer. And that regardless of who you are, we hopefully, it's not universally true, but hopefully we are answering your emails. You send us an email, this is my idea, can I set up a time to meet? And hopefully we will talk you through that idea and where it should go and help you figure out where in NSF we'd fund that sort of work. And so there is, if that the only way we can fund great ideas is if people send us their great ideas. So don't be afraid to talk to your program officer.
Okay.
Whether or not all program officers answer their phone equally quickly. And Jose, you have had experience with multiple program officers. You can attest to what that's like, but.
Yeah, I just know that that is really helpful. I know one of the things that some of my colleagues and myself have struggled with is figuring out which areas to submit things to sometimes for these, because once it becomes so interdisciplinary, it's like, who's going to know what area best? So, yeah. So
well, Right, and we struggle with that. So we fish
Yeah,
them
yeah.
around to each other, but but we can't do any of that effectively if you never talk to us.
But then again, what she's saying is true. That has been in my life. The best thing is to talk to the program directors. People be very happy to sort of talk about the different possibilities and stuff like that. Shoot an email. If you need to talk, set a time. If you have to talk to someone, people are getting lots of requests. Say, can we set a time to talk? They'll find a time for you. But people are very responsible. So that's the best way to do it. Don't go blank. It's based some communicate with people first before you send applications. Always a good idea.
Yeah. Thank you, Theresa. Thank you, Jose. And then, sorry, part two for the industry people is, for those of us who might be interested in industry, what is the best way to reach out to people like you if we become interested in jobs in a particular company? What kind of people should we reach out to when we become interested in a particular place?
So I think, Sarah, this may be a question for you. Yeah.
So in terms of Exponent, at least, and I think industry in general, so the CVs do come through on our website, but they often go through our HR, who's screening them for us before they even get to somebody like me or anybody else. But if you send me an email with your CV, I'm going to respond. So I will. Either I'll say I'm putting this over to HR to come talk to you, and they'll let you know or not. But I'm going to look at your CV if you send it directly to me. So our website, it's available. You can go on the website. You can look at the professionals. You can find what they do. Everybody has their CV posted. And if somebody looks interesting and maybe related to what you did, ping that person, send them your CV, say, by the way, I have a background in X, Y, and Z, and I'm curious to find out more about what you do. And that's going to differentiate you. And so that could be the place. Exponent does that. I don't know if every place does that, but if you can find a contact or an in, it's certainly going to elevate you in comparison with just submitting to a website, which can happen. It certainly is another way of going through, but it will elevate you.
Yeah. So don't poke HR directly, but poke someone who looks like they maybe have like your qualifications or something, has.
Yeah, I mean, if somebody's not related to me too much, I send it on to HR. I say, it looks like a mechanical department. HR, can you figure it out? And so, but if it is somebody with a similar background, I'm going to look at that person and maybe talk to them. So,
awesome.
I would also add that this is where you should use the network part of the PoLS network. If you shoot me an email and say, hey, I'm interested in working in this kind of thing, I'll check with the faculty, because all these professors have students who have gone off to do really cool things, and they will know somebody, and I can help get you connected. So if they don't know one of their own students, they'll have a friend who does something. So, the faculty are really connected. We'll get you a job.
Right. I'm actually trying to make notes as quickly as I can. Thanks, Margie.
I also wanted to mention, though, that I often ignore my LinkedIn people that it's a lot, and I'm just like, I can't do it. I can't do it full time, right? So I don't know. LinkedIn for me is not the place that I don't sometimes respond to those, but if it's a direct email and it is pertinent and it's clear to me you've done your research, then that's a different scenario.
Yeah, it's
or you go through someone like Margie who connects.
Yeah. If you connect and show that you've done something rather than click a few buttons on your business social media.
Yep.
Thank you so much for all the responses.
All right, do we have one more question? Anybody? Bueller?
I have a follow on when you trying to contact the people that you're trying to make connection with in order to send your resume. Making sure that you state what your impact is. What is it that you're trying to do? Because really, at the end of the day, you don't want just any job. You're a scientist. You have the skill sets that people want and need. And so, what is your impact factor? What is it that you want to do? How are you contributing to the greater good?
Yeah, I just want to add to that too, because I hear it and it makes me cringe every time. When I ask somebody during an interview, especially a full interview, what do you want to do? What interests you in this position? And they say, I just want a paying job. That's never a good answer. And maybe it's true a little bit, right? But it's not a good answer, I feel. It doesn't make me feel very confident that you're going to stay with us a long time if this isn't an area that you might be passionate about. And so I think it goes right on with what was said, that you need to convey why you're interested and your impact. So.
All right. Well, any other final thoughts from our panelists? Or Zane, did you have one more question, or are you good?
Oh, no, I'm good, Margie. Thank you.
Okay, all right. Any other final thoughts?
Just to add to that, when you do make these contacts, whether it's government, industry, other opportunities, if you identify a person that you really like and you're interested in their career, make sure when you send that email that it has a goal in mind. We're all bombarded by emails every day. So if you're very clear in why you're trying to contact this person, that you're interested and you have specific goals on wanting to reach out, maybe have a phone call to discuss, more often than not, you will get a reply. If it's very open-ended, you may not hear back from that individual. So just keep that in mind and continue to kind of work your networks and talk to others. And the idea is to really share your passions. The mentors that you have, touch base with them. Tell them where you're at, what you're doing, follow up. And that, they will also have, options to give back to you that where you're at now, have you considered this? Or if you refresh them on what you're doing, maybe a month later, you'll get an email saying, hey, I saw this opportunity. I thought about you. Here it is. So just kind of keep that. It really kind of touch base with your mentor network and keep it, keep it on the forefront.
One last thought. I mean, we all chose different career paths in ways we could see the impact we were having on science or society, but having an impact was something that was really important to all of us, why we stayed where we landed where we were. And so as you are looking, searching, whatever, where are you going to have an impact and what impact is going to be meaningful to you, I think is really important to think about. And as you're contacting people, we're all busy. Every once in a while, things are going to fall through the cracks. So just be persistent and spread your net widely. You will find someone who, for some reason, thinks something is interesting about your email and they will respond back. Be persistent, use all of your network, everything that all of my colleagues have said. And thanks for coming this evening to listen to all of us.
Well, thank you so much. I think we'll go ahead and wrap up at this point. I really appreciate y'all coming and being our panel today. It's been really great.
Thank you for having us.
Yeah, thank you.
Thanks.
And students, if y'all have any follow-up questions or want to connect with our panelists, just email me. You've got my address. So thanks.
Thanks for our panelists. Thanks, students, for joining us. It has been great.
Thank you again for the responses.
Yeah.